You need to be able to get these right, and I know we just learned it. Rewrite the expression in the form a plus bi. So you say to yourself, what does a plus bi mean? Isn't that mean the real part with the imaginary part? That's what a complex number looks like, okay? So we have a complex number subtracted from a complex number. Now this is a complex number because we know that that's really 4 minus, what is the square root of negative 1? I. So really you just have 4 minus I minus 5 minus I. Now are we multiplying these?
No.
We're not, right? I saw people multiplying. We're not multiplying. Look, are they right next to each other?
Yeah.
Are they right next to each other? Isn't it this complex number subtract this complex number?
Oh,
Okay, so it's subtraction, guys. So we have a negative 1 right here. Subtraction is the red flag one. This is the green flag. Negative 1 times 5. Negative 5. Negative 1 times negative I. Plus I. We have to distribute our negative through. Now this doesn't have a negative in front, so we just drop that straight down. Now isn't it just combining of like terms?
Yep.
Real parts with real parts, imaginary parts with imaginary parts. 4 plus negative 5. Negative I plus I. 0. So good job, Brigham and Brendan. Questions? Okay. So moving on. So 8-2 today. So we're going to be finding area of sectors, and then we're going to practice more with finding lengths of arcs, because that's super important. We did learn that yesterday. So we're going to first start off going over what we learned yesterday quickly. So 8-2, guys, you'll need to be taking notes. I don't know who you think you are. So guys, so first of all, yesterday we learned if you have a central angle starts from the center of the circle and works its way out. If you have a central angle, then it's equal to its intercepted arc. We know intercepted arc means the arc it opens up on, right, everybody? So we learned yesterday the length of this arc is theta. If you have a central angle, it's equal to its intercepted arc. And then also, we learned yesterday, okay, yeah, that is the measure of the arc, but now what if we want the physical length? Instead of degrees, what if we want the physical length? So we know if this is a central angle, then this arc is a measure of 60 degrees. If this is 60 degrees, this is 60 degrees. And we learned yesterday you can take any degree measures and you can convert it to radians. And you can convert it to radians so that you have a physical length, because pi over 3 is just 1.04. So then you have a physical, more tangible length instead of saying, okay, I want you to go 60 degrees, or I need 60 degrees of fence. Yeah, like that's not a physical amount, right?
60 degrees.
So remember, guys, 60 degrees and pi thirds, they're equal. One's in degrees, one's in radians. One's a measure and one is the physical length. We learned that yesterday. So we learned yesterday how to take something from degrees and convert it to radians. So we learned how to take theta, and we know that we multiply by pi over 180 degrees, right? Now think about it, guys. A full circle is 2 pi, yeah?
Right.
So wouldn't halfway around a circle be pi?
Right.
Isn't 180 degrees halfway around a circle?
Right.
Right, so look, isn't pi over 180 degrees just a fancy 1?
Yeah.
So we're not changing the degrees. We're multiplying it by 1, essentially. But it is helping us, it's converting it to radians. Does that make sense, everybody? So that's how come it's equal. We're not changing it, we're multiplying by a fancy 1. So let's take 200 degrees, let's convert it to radians. So we're taking 200 degrees, we're converting it to radians, so we're going to multiply by pi over 180 degrees. So we know that we multiply straight across, technically there's a 1, so that's 200 pi over 180. Now you take your calculator, we don't type in pi, we want a simplified fraction, you all need to be typing it in. 200 divided by 180, change it back to a fraction. 10 ninths. So this became a 10, this became a 9. So that is 10 pi ninths. So once again, 10 pi ninths is actually equal to 200 degrees. It's just this is the measure and this is the physical length of that. Okay, so now we're actually, yes.
Isn't there another way how you did it?
Well, no, we don't have angles.
No, that was what we did that. Just like that.
If you did it 2 ways. No, you put like
Time it all together.
Okay, so now we have to be able to go backwards, because sometimes there is an advantage instead of having radians, having degrees. So you have to be able to switch back and forth. Because let's say I said to you, okay, here's an XY chart, okay? I need you to draw pi fourths. Well, what the heck? But if you know the degrees, can't you draw in how many degrees that is, right? If I said draw in pi halves, would you know what to do? Probably not. So if you converted it to degrees, pi halves is 90 degrees. Wouldn't you know the 90 degrees would be right there? Yeah. Does that make sense, everybody? So there are times when you'd want instead of radians degrees. So now we have to be able to switch back. So what is so we're now going from radians to degrees. So we're given pi radians, we're given pi over 4, and we want to switch it. What is that equal to but in degrees? So now you're going to multiply by 180 over pi. So do you see how it's just the reciprocal of this? Everybody. Okay, 180 over pi. Okay, so now here's a little way to help you remember which one is which. So then with that being said, so if we're taking pi fourths and we want to go from radians to degrees, I said degrees second, so that's what goes on top, right? 180 degrees over pi. Now look, it makes sense of why we need pi on bottom. Because if we have a degree measure, we're not going to have pi, right? 200 degrees doesn't have a pi in it, right? Well look, isn't pi divided by pi 1?
Right.
So doesn't that take care of our pi? Yeah? And then don't we just multiply straight across? Isn't that how we multiply fractions? Okay. So we have 1 times 180, which is 180.
Wouldn't pi times pi be 2 pi?
No, pi divided by pi.
Well, then why are you timesing 4 by
You
180?
cross multiply.
I didn't multiply 4 by 180.
You said you're cross multiplying it.
I didn't say anything about cross multiplying.
Then why'd you get, yeah, you lost me with that whole cross multiply thing.
Is multiplication, does the order matter? No. So couldn't I write this as 180 pi divided by, 180 pi. Okay, Braylon and Jordan. If we switch 4 and pi over pi, multiplication order doesn't matter, right? So if you put the pi right here and the 4 over here, the pi's will divide out. Like order doesn't matter. So the pi, it is pi divided by pi, right?
Yeah.
So
So
it becomes 1.
divided by 4 then?
yeah, so it's 180 over 4.
So you just didn't switch it, you just kind of did it in your head.
Yeah.
Or how did you get 180?
So we have 180 divided by 4. What is it divided by 4? 45 degrees. So 45 degrees. Sweet. Now that's equal to pi fourths. That's just the degree measure. That was the radian measure. Okay. So I'm going to do number 1 with you on the worksheet. So we're switching from degrees to radians and radians to degrees. So we're given 300 degrees. We're asked to go from degrees to radians. So we are going from degrees to radians. I said radians second, right? So the radian part goes on top. So I'm going to multiply by pi over 180. Then we multiply straight across, which I'm hoping that at this point you guys are able to understand that there's really a 1 right here, right? So can I just do 300 divided by 180? Okay, so 300 divided by 180 is, change it back to a fraction, 5 thirds. So this is 5 pi thirds in radians. Questions on that? Okay, so now we're converting 7 pi 6, we're converting it from radians to degrees. So once again, I'm going from radians to degrees. What did I say second? Degrees. So the degrees part goes on top. So I'm multiplying by 180 degrees over pi. Now once again, Braylon and Jordan, all that stuff's being multiplied on top. Can I reorder it?
Yeah.
Yes. Well, 6 pi, I can reorder it because that's 6 times pi. Pi times 6 is the same thing. I'm not going to reorder it because it's an unnecessary step. Because we know we could. So isn't pi divided by pi 1? Yes? Right? Okay? And now I'm just going to multiply straight across. So I'm going to go 7 times 180. And then that's 1,260 divided by 6. You get what? 210 degrees. Good. So 210 degrees is 7 pi 6. But that's just the degree measure. Questions on how to do that? Okay. Now remember, if we're ever dealing with the physical length of an arc, we always want our degree measure to be in radians because that's a physical length. So remember yesterday we learned to find the length of an arc with a radius other than 1. Even in a radius of 1 this works. But S is equal to R times theta. Does anyone remember what S stands for? What is S? Arc length. Good. And then R is our radius and theta is our central angle, right? Everybody? But we need it in radians. Good. So guys, look at this first example here. If this is 30 degrees, that's our central angle. Isn't this arc, the measure of this highlighted arc, isn't it 30 degrees? Yeah. But now we are going to be calculating the physical length. So we will need that 30 degrees in radians. So we take 30 degrees, we multiply by pi over 180. So then you have 30 over 180, you simplify it down, and you get pi 6, okay? But that is not the end, right? Because, remember this, if we have a small circle and we draw a 60-degree angle, right? That's going to be a different arc length than if we have a huge circle and a 60-degree angle, right? So we have to account in how big is the circle, and that's why we account in our radius. So we're going to do S is equal to our radius, which is 4, times theta, which is pi 6. So we know the physical length of this highlighted arc is, if we multiply fractions, we multiply straight across. That'll be 4 pi 6, right? So then you take your calculator and you do 4 divided by 6, or you could say both of those divided by 2, this becomes 2 over 3, right? So the physical length of that arc is 2 pi thirds. Does that make sense, everybody? So we accounted in our radius in this one. Okay, so number 9 from the worksheet. Now make sure you're reading the directions. It says find the length of each arc. We're finding the length of the darkened arc, okay? So mine's highlighted, yours is darkened. So looking at number 9, we're finding the length of this darkened arc. So we need that specific central angle. So weren't we given it? So this is 120 degrees. What's the arc measure? 120 degrees. But now we want physical length of 120 degrees. So we're going to change that from degrees to radians. So we're going to multiply by pi over 180, right? So go, calculator, tell me what that is equal to. 2/3. So really this is 2 pi thirds. So now we can go ahead and use our formula. So arc length is equal to our radius, which is 12 miles, times theta, which is 2 pi thirds. Now think about it, guys. Aren't we technically multiplying a fraction with a fraction? So don't we multiply straight across? So we're going to have on top a 12 times 2, which is, so 24 pi, and then on bottom 1 times 3. Now you take your calculator. Does 24 over 3 simplify?
Yes.
Yes? It's 8 pi miles. Okay? We were talking miles. So, guys, if I said to you, I need 120 degrees, if I gave you this and said, okay, I have a field with a diameter of 24 miles, so wouldn't that be a radius of 12 miles? And I said, I need you to build a fence of 120 degrees. Well, you would need to know how much fence you would need. Well, now you know, 8 pi miles, right? That's how much you need worth of fence. So I want you today, this is the mathematical answer. If you were an engineer, you're not going to want 8 pi miles, so type it in. 8 times pi, go, type it in. So 8 pi, was everyone able to type it in? So we need 25.1 miles of fence. Does that make sense, everybody? Okay, so I need both answers today, the mathematical answer and the engineer answer. Okay, questions on that? Okay. Number 14, then I'll let you work for a while, okay? So number 14, it doesn't give us a picture, but our directions are still find the length of the arc. So we know that length of any arc is S is equal to our radius times theta. So S is equal to our radius, which is 6 kilometers, times theta, which is 225. But can I put in 225, or do I need to put in the radian measure of 225? The radian measure. So I'm going to convert 225 times by pi over 180, so we can have it in radians. So I'm just going to do multiply by pi over 180. So we have 6 times what?
5
pi fourths, right? Is that what you got? Okay. 6 times 5 pi fourths. So now we just multiply straight across, right? Everybody? So isn't that 30 pi fourths? Now you take your calculator. Does 30 over 4 simplify?
Yes.
Yes, and it is what? 15 over 2. So that's 15 pi halves. So we have 15 pi halves kilometers, which is equal to, the engineer answer would be, how many kilometers exactly is that? 15 pi divided by 2. That's 23.6 kilometers.
15 pi divided by 2.
Okay. Questions on that? Are you ready to go?
Yeah.
Okay, sweet. So you're going to do problems 9 through 16. Okay, guys, so we've got to be good at at knowing something and then maybe given some more information different than what we are used to being given. So, looking at this example, on number 17 on your worksheet, it says, find the angle measure of the arc. So first of all, you say to yourself, okay, I know that arc length is radius times theta, right? So we know we're using the formula S is equal to R times theta. So now we're asked to find the angle measure. So won't we be finding theta? Okay, so now notice we're given the radius and then S. So we're given the radius and the arc length. So we know that S is equal to R times theta. Let's put in what we know. S is 10.8, right?
Yeah.
Which is equal to our radius, which is 4, times theta, which is, we don't know. Now aren't we just solving for theta? So do you see how we only have one unknown? So this is a way of, making sure that if you're given an equation, or if you know an equation and you're given some things and asked to find something different, put in what you know and then see, can I solve for theta now? So yeah, what would we do to get theta alone?
Divide by 4.
Divide both sides by 4. So 10.8. 2.7, and it was feet, right? When we done the feet. So 2.7 feet is equal to theta. So let's think about it. Isn't theta a central angle? Because a lot of people get thrown off. They're like, what the heck? What do you mean theta is 2.7? But remember, can't, so I'm going to draw a circle. We know if theta is 2.7, that means that, so if this is theta, isn't this equal to the arc?
Yes.
And can't that arc be changed from degrees to radians?
Yes.
And then can't that radian be calculated to be an actual decimal?
Yes.
So we're just writing the actual decimal value here. And that's fine. I don't need you to go backwards now. It would be too hard to get the angle measure.
Oh, okay.
Do you get what I'm saying?
Okay.
This is good enough. Okay? Do you get what I'm saying, everybody?
So,
Okay. Because remember, angles can be written as radians. Radians can be written as decimals. That's what we're looking at with these, which is fine. Okay, so ready, set, go. Do 17 through 20. Okay, so first of all, we're going to now be finding area of circles and sectors. So first of all, I want to remind you, this should not be new to you. You know how to find the area of a full circle. Now I need you to remember, what does area mean? That would be filling in the full circle. Does everybody understand that? So that's different than arc length, right? Different than arc length. This is filling in the full thing here. So the area of a full circle is pi r squared. Pi times the radius squared. That would be the amount filled in for that particular circle. Pi r squared. So now that's not new to us, but this is new. So now we have to be able to find area of a sector. So if we have this circle, and I only want to find the area of this sector, sector just means section, okay? So I only want to find the area of this section of the circle. So this is how you'll do it. So you'll take theta divided by 360 times by pi r squared. Now I do want to relate this, and I want to have you think about this because this will make it easier. If you're just trying to memorize the formula, you'll forget. I'm going to help you make sense of the formula, you guys. So everybody look up here for a second. If we want to find area of a full circle, it's pi r squared. Now area of a sector is theta over 360. Isn't that saying we're taking this amount divided by the full amount? So it's still times by pi r squared, right? So now all we're doing is saying, okay, we know area of a circle is pi r squared. But we don't want the full circle, so we've got to take the amount we want divided by the full amount and multiply that in. Does that make sense?
yeah.
So a section divided by the section you want divided by the full circle times by pi r squared. So it's very similar. It should be easy for you to remember. Questions on any of that?
So the answer to that would just be a fraction of what the area we're trying
Right, yeah, it's just a fraction of the area that we're trying to find. And so it's really the same formula. We're just, we're putting it in, so we only want this section out of the full area. Okay, so here's my first example here. So find the area of this sector. So once again, you see that we're finding the area of this section. So this is how you say it to yourself. I know area of a full circle is pi r squared. But now we only want this section. That's 50 degrees out of 360, right? Everybody? We want the area of 50 degrees out of the full circle, which is 360. Then we're going to multiply by pi r squared, because that's how we find the area of any circle, right? So times by pi, then our radius squared. Our radius is 2 squared. Now, guys, when we're multiplying fractions, we multiply straight across. So I hate to have to do this, but don't we know that this is over 1 over 1? Okay, so let's type it into our calculator. Do not type in pi, because I want the answer in terms of pi. If you type it in with a pi, your calculator can't put it back in a simplified fraction for you. So type in 50 times 2 squared. Enter, divided by 360. Change it back to a fraction.
So you can't go like 50 divided by 360
You
then times.
You could do that too. Because isn't multiplication and division, there's not one that's order of operation above the other, right? They're hand in hand, so it won't matter if you divide first or multiply first. Okay, so you get 5 9ths, which is 5 pi 9ths, right, guys? So the area of that section of the circle is 5 pi 9ths, and we're talking meters. So, I want both answers. That's the mathematician answer. Now, 5 pi 9 is 1.7. I typed it into the calculator, 1.7 meters. So, you guys understand, hopefully, that that's not the length of the arc. That's filling in the area of that section. Does that make sense, everybody?
So
You gotta know the difference.
how is it only 2 meters if it's, wait, so the radius is 2 meters and that area in there is 1 foot?
Well, think about it. I mean, the sliver must just not be that big. Think about it. If you have
Oh,
it,
it's not-
you know what I mean?
It's not proportional.
It might not be drawn to scale.
Okay.
Good question. Yeah. So it could be a teeny sliver, which could be less than that long radius. You know what I mean? Okay. So number 21 here. So we're finding the area of the sector. Now make sure you're finding it of the right portion. So we want the darkened sector. Do you guys see how my highlighted sector would be the darkened section on your paper?
Yes.
Okay, so we're finding the area of that sector. So our theta is 270, right? Now you don't need to convert this to radians because in the formula for area, it converts it to a physical length for us. Okay, so we know, okay, we want the area of this section of the circle. So we need to take the section, which is 270, divided by the full circle, and then it's pi r squared. So pi times the radius squared, so 12 squared. So we can just type it into our calculator. There's many different ways of doing it. This time I'll do 270 divided by 360. I hit enter, then I multiply that by 12 squared. We get 108. So our area is 108 pi, and that was yards. So there's 108 pi yards in that filled in circle or filled in section of the circle. 108 times pi, 339.3 yards. Fill in that section of the circle. Okay? Questions on that?
Wait, so we're going 2 decimal places? Sorry, that's a stupid answer.
No, that's, I mean, yeah,
Okay.
1 or 2. Okay, finish the worksheet. The rest of the time is yours.